All right, welcome to WASA Distance Education. This is MBF3C, grade 11 college prep math. I'm Pete, I'm your teacher, and today we are starting our review for the final exam. So we got through all the coursework, and I hope you didn't miss me when I was on pre-record for a couple of days there. Now, if you have any questions at all, you're welcome to contact me, and you'll be able to find me in the office during my office hours. You can email me. You can reach me on Facebook, PW space WASA. So what we have left now for you, Monday is a holiday, so there's no class on Monday. So don't show up Monday expecting for a class because you will be disappointed. So we have class scheduled for Tuesday, Wednesday, Thursday. Now, one of those days next week, and I probably won't find out until, well, later today. I may not be here, but we're going to sort something out. Okay, we may not need that extra day. So, but I'll give you some more information on Tuesday. So in the meantime, let's get started with the review then. Now, as far as the final exam goes, basically you've completed your 20 lessons. Okay, so we're not doing a culminating activity in this class, so the final exam is gonna be worth 30%. But you've done your 20 lessons, you've done well, and so now it's just the final exam. Okay, so don't stress over the final exam. Do your best. The way to tell that you're ready for the final exam is to go through the key questions and in each of the chapters and say, could I solve that? Do I know how to solve that one? Okay, and so you're just going to have to make an attempt at every question on the exam. Okay, that's the other thing. Okay, if you're not 100% sure how to solve a problem on that final exam, solve it anyway. Do what you can. Okay, write something down because you're just trying to get marks at this point, right? That's what you're trying to do. So one of the things I do for you is give you a formula reference sheet because it is a closed notes exam. So this is the formula reference sheet for your exam. It'll be on the back, and you can just pull it off. Now, do be careful with it because depending on how the exam gets printed, there might be a question on the other side of it. So you might have to put it back with your exam. So you're going to be given a vertex form. You're going to be given simple interest, I equals PRT, and the compound interest formula, A equals P times 1 plus I to the power N. And you're going to be given the present value formulas, and I gave it to you in the two different ways, so you don't have to work through and try and derive the regular payment version. You've got both versions there, and the same as the annuity formula. So do watch that because there's two different, slightly different versions of these complex formulas. So make sure you're picking the right one. If you're asked for what something's worth now, um, or if you're asked for, yeah, what your regular payments would be, you're using the present value. And if you're working out an annuity, something in the future, you're making payments to take money out in the future, not buying something now, then you're going to use the annuity formula. All right, and then we given a resale value formula for used vehicles, usually for anything used, really. So you're given that. I give you the trigonometry ratios. You probably know that one, SOHCAHTOA, but there it is, just in case you get nervous, because sometimes people get nervous, especially if you're not writing that many exams, right? If you're in a high school, you probably have 5 or 6 exams to write. You go sit down and you write them in the gym. You do that a couple times a year, and you kind of get used to it. Um, but in a class like this, maybe this might be the only exam you've written in a while. So I understand all that, and that's why I'm giving you this information here to use. So I give you the sine law, and again, it's two different ways. Okay, so and just in case just to help you remember it, I'll give you the cosine law. Now this is right out of the book. I think you know by now that I don't actually really value memorizing this. The three different variants. I prefer just to know the pattern and just kind of work it out each time with the angles that I have and the sides that I have. But anyway, there it is. Okay, and that's it. That's everything, because everything else is knowledge, and that's why if I give you this page, it really doesn't you still have to know the material, right? You can't really pass the exam just by knowing this, but this will hopefully put you a little bit at ease. You don't have to worry about, forgetting one of the big formulas and then, getting crushed on the exam for that. Okay. So that's it. Now let's get started. We'll go through. I'm going to go through Unit 1 and maybe a little bit of Unit 2 today. We're going to try and get through at least the 3 units. We've just done Unit 4, so probably not. Don't really need to spend a lot of time on it. All right, I'm going to close this. Let's see if I can do that. Okay. Oh. Okay, there we are. So this is Unit 1, way back when we started here about almost 9 weeks ago. And you'll remember that Unit 1 was all about parabolas. And we learned some kind of important characteristics of parabola. In vertex form, the parabola has a certain, let's see, we passed. Just got to skip all this introductory material. Okay. Um, there we go. Yeah. All right. So yeah, so you saw that we had the option of having some tests and quizzes, and if I thought it would help you, you might have written a quiz in this course. But generally speaking, if you're doing, you're getting good marks in assignments, you probably don't need those marks for a quiz. You see, from a quiz. So here we are. And we're on page 6, and we gone way back to Unit 1. So there's 2 ways that we write parabolas. Now in this course, we really only studied vertex form. We didn't really do too much with standard form. So if you've taken some classes before, especially in say grade 10, you would have probably mostly done standard form. So I just showed it on here just to give you an idea that there are 2 different ways of representing the same thing, right? It's the same parabola. If you graph them, it'd be the same, but it's just a different way of presenting them. Okay. So the nice thing about vertex form is that the H and the K are your actual. That's the that's your minimum or maximum, right? That's the vertex basically of the parabola. And for some of the questions that you're being asked, that's important to know, right? The diver question that everyone's looking at, going, how am I going to do this? And then when you find out that all you just need to do is look at the H and the K, and especially the K, I think it was what it was, the height, then then it becomes a much easier problem. And that's the point, right? Is to see when you first look at it, you go, oh no, and then once you realize that you have the knowledge to solve it, it becomes quite easy. So the vertex form, then we have our A, which is the same as the standard form, and then it's x minus h squared plus k. Now the complicating fact is that the h itself can be positive or negative, and it fits into a format that includes a negative sign. So every once in a while, if h is negative, we end up with a plus sign there. Okay, so I tried to kind of show you a way to remember that. But here we go. So the A just determines whether the parabola opens up or down, right? If A is positive, it opens up just like it showed right there, U for up. And if it's negative, it opens down. That's really all A does. A also determines whether it's a little wider or narrower, but it's really hard to see, so we don't even really talk about that. Okay. So that's it. So the value of A, if it's negative, it just opens down, and that's really all it does for us. Okay, but that's an important thing because as soon as you see it, right, in vertex form, you already have in your mind an idea of what the parabola looks like. And you can probably sketch it, right? Especially when then you look at the H and the K, because the H and the K give you the offsets, and then it also tells you where the vertex of the parabola is. So it's a very powerful thing. Okay, so we have that. We didn't really have to spend a lot of time on opening up or down. The biggie was this, H. And whenever we plug H in, I suggest that you use brackets like that so that if h is negative, that'll alert you to the fact that your final expression is going to have a plus sign in it. Okay. Now, if you see something that says x plus, then it means that your h is negative, and it means that your parabola is shifted to the left. Okay, so in vertex form, the value of each shifts the parabola to a certain number of units to the right if h is positive, and a certain number of units to the left if h is negative. The problem really is that when you plug in the h, and especially when it's negative, like I've shown here with this example, um, you're going to end up with x plus 3. And it's sort of counterintuitive. You would think that plus would be shifting it right, but in fact it shifts it left. And the reason for that is that the vertex form has a negative sign built in. So when you plug a negative number in there, and then you distribute that negative sign, which is a -1, it changes the sign, and you end up with a positive value in that spot. But actually, that's not h, right? Because to find h, you have to put a negative sign in front of it, which means that you have to turn the value from positive to negative, right, in order to do that. Okay, so yeah, so maybe I'll add another one here. So if I have y equals 2x minus or x plus 4 plus 1. Okay, so when I look at this, okay, I'm not looking at the value of h there. You got to be real careful. In order to know what the value of h is, you have to make that negative. All right, so what do I have to do to 4? If I'm multiplying something by -1, basically, what does that value have to be for us to get a positive? Well, the signs have to be the same, right? So this is what the expression actually looks like when we put it in standard form. And this is the h value right here. You see, that's, really in this whole unit 1, I think that might be one of the trickier things. Once you get it, you're fine, right? It becomes second nature. It's just how to get into that point where you understand this, why it is that when we see a plus, what it means here. In matter of fact, I can sketch this whole thing now, right? This is my x, this is my y. It's positive, so we're opening up, right? It's the h is negative, so we're shifting left 4 units, and the x is, or sorry, the k is positive, so we're going up. So it's going to be something like that, something like that. Ooh. Okay, well, that's twice I, all right, I'll try that again. Okay. I'm kind of, there we go. Okay. And so you can say that, and then the other thing there is that you can then say, well, so this is h and k, right? So that's 4 and 1. There we are. Okay. So that's how the parabola is going to look. All right, so, and I showed you the rules. So you should have this thing, this should really be on speed dial. You should have that memorized really, really thoroughly. Okay. And then the last little bit was the k, which just shifts it up or down. Okay, it doesn't really, it's pretty straightforward because either positive or negative, right? It is plus, but we have a little easier time when the format is plus, because if we're adding and it's a positive number, then it's just positive, and if we're adding and it's a negative number, then in fact we're just subtracting, right? And the reason for that, let's say that that was -5, right? So the pattern then is plus, and then the k would be -5. Well, remember that this is basically +1. Well, what's +1 times -5? It's -5, right? So that's why if it's a positive or a negative, we just put it in there. We don't have to worry about the sign at all. Whereas this one, because the negative sign sitting out there, it'll actually um, change the sign depending on whether the value is positive or negative. Okay. So when you're thinking about the final exam, right? What you really want to do, you could go through the support questions. What I would suggest you do is go through the key questions and just kind of look through the answers you got. Look through my notes, right? Because very often if you're having problems, I'll put an example down or something, or at least it'll give you an idea that you need to contact me and get some help before the exam. Okay. But basically go through these ones and try and do a few of them. Some of the ones that you did well on, that's fine. I would focus on the ones that you had problems with the first time around. Okay, and try and do those. Okay. Okay. So it's going to ask you to sketch some stuff and probably ask you, what the different values are. They tend to, the exams tend to kind of focus on, oh, geez, a lot of extra pages here. They tend to focus on things like this, okay? Where they just want to know everything, right? So they're not really breaking it down. You're just going to do, um, tell them the A, the H, and the K, and what it transforms, what it changes, right? So for example, the A, it opens up or down, right? The H, it'll shift it left or right, and the K will shift it up or down, right? And so be prepared to be able to state the A, the H, and the K. Okay, the actual H. And I think if I look at all these, it looks like they got, the special cases like this. Make sure you know how to do that. That's kind of a weird one there. That's another weird one. And I noticed that they don't have any negative H's. That's which means that all of our H's here are positive. It's kind of a strange omission. Yeah, here's the one with the diver, where it's a big long question, and what it says is what is the maximum height, and what they're basically saying is, do you understand that the vertex form of an equation, the h and the k are the coordinates of that vertex. Okay, that's the whole point. Okay, even though I know the course material didn't spend a lot of time explaining that, that's the whole point of putting something in vertex form, so you can easily look at the equation and get the vertex. So if you're given a question like that, chances are, unless they're asking you to solve for y at a certain value of x, then really what they're asking you in this case is what's the vertex. Okay, and in fact it's the k. It's the k value. That's the maximum height right there. Okay. Okay, and the h the h is just it doesn't really help us much here because it's kind of it's not even the center of his arc or of his parabolic dive, because some of the parabola, if we graphed it versus the physical situation, some of that parabola is within the cliff, which it doesn't make a lot of logical sense for it to, right? We're modeling it with a parabola, but some of the parabola doesn't match up with reality because it's inside the cliff. Okay. All right. So you'll be able to, I'm sure you'll be able to do something like that if they give you something weird like that to do. All right. Now, the next thing we looked at was we started to look at in the next couple of lessons a bunch of tools that we needed to be able to do to manipulate quadratic equations of problems. And they're talking about a second degree polynomial. That's a really fancy, complicated word to mean that the highest exponent in the expression, in the equation, is a 2, right? So now you know what that means. Second degree polynomial means that square is the highest. A 2 is the high. If you had one that was a 3, right, then it would be a third degree polynomial. If you had one that was a 4, it would be a fourth degree polynomial. And I betcha now you're off to the races, okay? And you better hope you don't really encounter a third degree or anything higher polynomial unless you have a pretty fancy graphing calculator, because it gets really hard to do these by hand after that. Actually, that's um, the by hand tool that we use for anything higher than that is calculus. That's what allows us to crush polynomials and anything else that has a higher exponent than 2, right? And that you take the grade 12 class to learn that. So now, um, let's see, polynomials. Okay, so polynomials just they have terms which are variables, and they have whole number exponents. That's really it. Okay, and then polynomials are kind of joined together by addition and subtraction. Okay, um, so each term, um, yeah, so they're joined together with positive and negative plus or minus operations, and then you get a polynomial expression. Okay, uh, this was just kind of useful stuff. Okay, um, but the actual stuff we wanted to review here started right on the bottom of page 13. Okay, and we're using the distributive property to allow us to simplify or to work with these polynomials. Okay, so you may have heard of FOIL before, and FOIL works when you have two things. When you have two things in brackets, but when you only have one thing, like a constant or a variable, okay, we use the distributive property, and it's the same idea. FOIL is just a way of keeping track of bookkeeping when you're working with two binomials, right? So, but for the distributive property, then when you're going to multiply something, you're just going to multiply the first term, and then you're going to multiply the second term. Now, be careful that you pick up the signs, and you know that my um, the way that I teach you to do it is to work out the signs first. Now in this case it's pretty easy, but let me just make it a bit more complicated by changing that to a -2. Okay, so now if we're going to solve this one over here, -2x times x. So we have a negative times a positive, so I'm going to put the sign down, negative. Why did I put down negative? Let's go over to this little chart that I made here. If the signs are the same, the result's positive. And if the signs are different, then the result's negative. So over here, if we had a negative times a positive, signs are going to be negative. 2 times x is 2x. To me, that makes it much easier because then you're only dealing with one idea at a time as you're trying to solve these. You're going to get the sign sorted out, then you're going to work out the actual value. All right, well, let's try the second term here then. So we have +1 or +1, and we have -2. So the signs are different. Going to be negative, and then 2 times 1 is 2. Okay. Okay, so that's how it works. You work out the sign first, then you do work out the numbers, the values, whatever. Okay. So, and you can practice a few of these. So now the other thing that can come up is that you're going to be given the value in front of the parenthesis might actually have a variable in it, might be a variable. Don't let that throw you. Now they show it this way, they show an extra step. You're welcome to put that extra step, but basically you're going to do it the same way. Okay, so it's going to be, so 2y times 3y. So here's the way we do it. We do the numbers first. What's 2 times 3? It's 6. And then y times y is y squared. Okay, that's it, y squared. Okay. And now for the next one, we do the same thing. So we're going to work out the signs. I got a positive times a positive. Result's going to be positive. I have a 2 times a 2, which is 4. And I have a y times, well, this is the thing, right? There's no y to multiply there. Okay? So if I were to actually write this out, this is basically going to be 2 times 2y. Okay? And that's just going to be 4y. And for the same reason, that's going to be 4y. Okay, so if there's variables to there and there's nothing to multiply them with, they just come along for the ride. Okay. Okay, that was a pretty lousy looking 4y there. Okay. So that was the distributive property, which is just basically a simplified version of FOIL, right? We're doing part of FOIL, but we just don't have, we only have one term at the front of the brackets. Okay. So now, at the bottom of page 14, here's what they're going to do. They're going to show you how to do this with FOIL. Oh, okay, I wrote it over there. And basically, FOIL is an acronym or a mnemonic. Now, that's not on the formula reference sheet because it's really not a formula. It's kind of it's a, I don't know what it is called. It's a tool. So FOIL stands for front, outside, inside, last, right? And if you remember that, you go through it, then you're going to be able to keep track of what you've done. Basically, you want to make sure you've multiplied each term in each expression by all the other ones that you need to, right? So it's just a way of keeping track of things. But it's also important because just about everybody does it that way. It's very, very, very rare to find someone who's been doing math for any length of time who doesn't use FOIL when they're doing this, which means that if somebody's looking over your work and you've done it in a different way, it causes, it can be very difficult for them to follow, even though it might be correct. Okay. So FOIL, we're just going to do the front. We're going to show it here, right? And we do it the same way. So this example that they do it here, 2x plus 4, okay, x minus 3. Okay, I'm just going to scroll down a little bit. So now they show the intermediate steps, and I don't know, you can use the intermediate steps. I just do them directly. So I have 2x times x, 2x squared. Now, the reason I just skipped to the multiplying the variables is there is no coefficient there. It's actually a 1, right? So 2 times 1 is 2, right? So, and then x times x. So if there's variables, you multiply them together. If there's numbers, you multiply them together. And if there's a mix, if there's ones missing, then you just don't do that step. You just bring that number along for the ride or that variable along for the ride. So there's the front, F, and then the O is the outside. Okay, so you got to watch it because in this case the negative sign is part of the expression. It's always going to be the sign between the terms, and the sign in front of each term for the first ones is always going to be part of the calculation. So I have a positive times a negative, my result's going to be negative. Now I have 2x times 3. So in this case we don't have the x. So 2 times 3 is 6, and the x just comes along for the ride. Okay, so that was the front, the outside. I'm going to change color, and we'll do the inside now. Okay, so there you go. There's the inside. Okay, and again, we have the positive times a positive. So that's going to be positive, and I have a 4 times x, and that's just going to be 4x. Okay, there's nothing corresponding, right, to multiply together. The x has an implied 1 in front of it. That's why things worked out the way they did. And then finally, we have last. Okay, and we have a positive times a negative, so the result's going to be negative. 4 times 3 is 12. Okay, so now we have everything worked out. Now the next thing we need to do is this idea, it's combining like terms. Okay, that's a very important step because right now we really can't use this for much because it's not in any kind of standard form. But once we combine our like terms, then it'll actually look exactly as we're expecting a quadratic equation in standard form. So I'm just gonna let's go back to green here. So you're gonna start recognizing a pattern if you do enough of these. You have the 2x squared. That doesn't change. It's these middle two terms that you usually have to combine. Sometimes if you're doing a multiplication like this and then there's additional terms outside of the multiplication in the equation, then you'll have to combine like terms at maybe a second time. So I have negative 6x plus 4x. So it's negative 6 plus 4 should be negative 2x and negative 12. Nothing to combine there. So there we go. We're done. Okay. Now, if you're ever checking something like this, or ever working on it, of course, having a good graphing calculator really helps. Having a good, there are calculators that will solve these. They're kind of pricey, and unless you're planning to go to, higher education and do this stuff, it's probably not worth it. But maybe if you're taking a grade 12 calculus class, it might be worth it. But for this, I think just doing it by hand is fine. But if you wanted to check them, you can go to their online calculators. Just look for uh, um, quadratic equation solver or parabola solver, and yeah, you can go and they'll factor them or whatever you want to do. Okay, so it's always handy to be able to check them. Okay, so we went through all that, and the main thing is to to just practice. And it's just backing up a little bit. This is on page 15 of Unit 1. Um, if you need to put that line in, I skip right to this next line. Okay. But if you need to put that line in, that certainly can be very valuable because then it can help you organize everything, right? You just do one extra step. Okay. So now, as you're getting ready for the exam, one of the things you can also do, if you're not unsure, of course you can always call me, and I encourage that. But you can go back to YouTube and watch the videos on YouTube. You can go to the WASA archive on the NNEC website. You go to NNEC, and then there's a link. It says WASA Distance Education. It's up near the top. You click on that, and then you'll get a little drop-down menu. And one of them is a WASA class archive. You click on that. The instructions to do that, including some pictures on how to do it, are in your study guide that you got with the course. Or really, if just find anybody's study guide. It doesn't matter, because the last few pages should show you how to do that for any class's study guide. Okay, so that's two ways to get the videos, and the difference is that the ones on the archive, you download the whole thing, and then you can watch it, and you can kind of put it on your memory stick, and you have it. And the YouTube one, you just sort of, it streams it, so you watch it, just sort of whatever bits and pieces you want to watch. All right. So here we go. You got lots of practice here. The support question, you can do a few of those. There are things like this here for C. Okay. I don't know what I just did there. See if I can back out of that. Okay. All right. A little bit of housekeeping here. I'm going to lock in place. It's one of the weird things about their software. I wish there was a command to lock all the screens. What it is that when I convert the text into like for the smartboard, it leaves the text kind of as a floating object behind the ink. But sometimes if I touch it, and I can move it, and you can lock each page, but there's no way to tell it to lock every single page in the book, at least that I can find. Okay, but this is the thing, right? Knowing the strengths and weaknesses of our tools is probably part of the game here. Now, what do I do? I'm in a strange mode here. So 4C is a type of question. Now, this can really, this sort of thing can be challenging, but what you really want to do here is you basically have three things you're multiplying together, right? Think of 2 times 3 times 4. Right? Now, it really doesn't matter if you multiply those two things together and then multiply the result, right, by 4, right? It doesn't matter. Or if you multiply those two together and then you multiply the result by 2, it doesn't matter. And in this case, it doesn't matter whether you multiply everything in that first bracket by -8 and then multiply the results together, or just save this and then do your FOIL on these two and then multiply the result by -8. It doesn't matter. What's important is that you don't forget to multiply the thing by -8. Okay, and that's really where just doing a bunch of these questions and finding out you forgot a couple times probably help you to remember that. Okay. So I'm going to actually show you how to do that one here. Okay, plus Okay, so I've just made another page. So this is support question 4, and that's on page 16. And of course that's unit 1, lesson 2. Okay, so we have -8, and then it's 3w minus 7y, and 2w plus y. Now, notice that they haven't given you x's and y's. They're giving you more than one variable. They're just trying to throw you a little bit, make it a little harder. But, basically, if you're multiplying w's by w's, then they become w squares. And if you're multiplying w's by y's, then they become wy's, right? Now, and the reason they don't become yw's, they could, it wouldn't be wrong. It just, we normally list the variables in alphabetical order. Okay, and you'll see why when I actually do this. So what I'm going to do is I'm going to leave that -8. I'm just going to do the FOIL on the second 2 here. So front, so it's positive times a positive, so I have 6w squared. Outside, okay, and it's a positive times a positive, so I have plus 2 wy UVWXY. Okay, so WY. It's got to be WY. That's alphabetical order. All right. Inside, and change colors. So inside, going to be like that. So it's a negative times a positive negative. And I have 14. And now it's going to be Y times W, but remember, I'm going to put it in alphabetical order. So WY. Okay. And then last. So it's a negative times a positive. So I have negative 7y squared. Now, you see what happened in the middle 2 terms? We put the 2 variables in alphabetical order, and they're the same, right? If we had put them in the order where we multiplied them, one would be wy and one would be yw. Okay? So, and then those are a little harder to recognize. But when it comes time to combine like terms now, it should be a little bit, should be obvious. I have 2wy minus 14wy. Let's see, that's going to be minus 12wy minus 7y squared. And I think I probably, when I was talking about that up a little higher, I think I don't know my alphabet. I think I said YW was alphabetical order. Yeah, it's right. X, W, X, Y, Z. Yes. Okay. So it's W and then Y. Okay. If I was good at the alphabet, I'd be teaching, well, not math. Anyway. So there we go. I think we've got, take a look again, make sure we get all our like terms combined. Yes, we have our like terms combined. Oh, I almost messed up. You see, we would have looked up in the end, and we looked in the answers, and I would have said, oh, I got the wrong answer. You see what I did? And this is exactly why. That -8 was kind of here the whole time, and I just sort of forgot about it. It was just off in, kind of hiding in the corner there. And this is why we've got to look at things in math, right? Really important. Step 4 of our 4-step problem solving model. Get to the end and look back and say, all right, is this the right solution? Did this work? Okay, so I looked it over, and so now I get to distribute this -8 across this expression, and that's really all it is. Not right. We could have done it on the first term in the first line, -8 times 3w, and then times -7y, and then gone through the process. But this way it gives us the same result. So let's see. So I have a negative times a positive, so that's going to be negative, and then 6 times 8 is 48w squared. Now I have a negative times a negative is plus. Now 8 times 12. Quick, what's 8 times 12? Well, grab a calculator. I got 96, and it's going to be 96wy. And I have a negative times a negative for the -7. That's going to be positive. And 7/8, I think 7/8 are 56. Whoops, 56y squared. There we go. So now we're done. Okay. and that's all. That's all there is to it. Now, when we're organizing expressions, terms, we organize just again, it's a style thing. If you forget to do this, I'm not going to take any marks off. But normally, we arrange the variables in alphabetical order, and then we also arrange the terms so that the variables are in alphabetical order. So the W starts first, um, and then the Y comes at the end. And also, we put the highest exponent first. So what it means is that if we follow these rules, then no matter who in the world and where you are that solves this, you'll actually come up with the same answer in the same format. It'll always look like this, right? No matter who does it, if they're following the same rules. And, it's just, they're rules in the sense that this is what everybody does, and, we no one's going to take marks off. At least I'm not. If you had 56y squared minus 48w squared plus 96wy, yeah, I'd probably write a little note on there to show you how it should be, but wouldn't take some marks off. Okay, so that's an example, and so try some of those and make sure you're good at them. And then for the key questions, I just want to show you a couple of key questions here from this. You might see something like this on the exam. Okay. It's this one right here. It's question 5. So this is on page 18. So unit 2. It says write a simplified expression for the area of each object given below. Okay. So what they're asking you to do is substitute a algebraic expression into a formula that you know. So in this case, it could be area, right? The area of a rectangle. It could be the area of a square. It should be something fairly simple like that. And then basically, so the side lengths are not given in numbers, are given as a variable. And X could be, we don't really know, okay? But in manufacturing, right, it might be, the X could be the number of items that they're going to put in the box, right? Maybe it's sneakers. Well, sneakers are probably not good. Maybe it's Cadbury cream eggs, okay? Yeah, Cadbury cream eggs, okay? So, because, Easter coming up. So the X might be the number of eggs you want to put in the box, right? So if it's 6 eggs, it's going to be a certain size, and if it's 12 eggs, it's going to be another size, and if it's 100 eggs, right? So they have different sizes of boxes, and their boxes are standard proportions, but the actual physical size of the box is going to depend on how many items they put in the box, right? Now, X could be some other things. X could be, well, yeah, I guess it could be the weight of the thing, maybe, depending on what type of box they're making. It could be the one of 3 different sizes that they have for the product, right? Maybe they're selling skis or something, and there's 3 different sizes of skis, and so, the box, they'll pick the size of the box depending on which size of skis they're shipping out, okay, or which, what they're making for that particular run. Anyway, the point is that when manufacturers design stuff, they sometimes design that sort of flexibility in there. So they're not designing a box that's for 2 cream eggs, right? Because next month they might want to sell 3 cream eggs, and they don't have to redesign the box, right? They just change the computer, they change X from 2 to 3, and it starts cranking out boxes that'll fit 3 cream eggs instead too. So whenever you have something like this, it's just a matter of, so let's say that we gave you a square box, which because the sides are the same length. They put the line across it. It could be a 2x plus 1. It could be anything. And all you have to do there is the area formula. It's just a side times a side, which in the case of square is just s squared. So you're going to substitute down here. In this case, a equals 2x plus 1. Now you have a couple of ways to go. You can write it that way if you want, or you can write it this way. Okay, and once you have that done, you're off to the races. You can solve that, and you're going to end up with a quadratic equation that gives you whatever they're looking for, the size of the box or area, in this case the area, it could be the length of the box, right? It could be a lot of different things. This is how this type of equation is used in manufacturing and in business. Okay. Now, the next thing that we saw, and I didn't really review it all that much, but we saw factoring. So factoring is the opposite of using FOIL, of using your distributive property to kind of, in the case of FOIL, you have it as two binomials multiplied together, which is very useful. There's a lot of reasons we'll use them. So sometimes we have it in standard form and we want to get it into two binomials. And that's where this factoring comes in. Let's just back up a little bit here. And actually, no, I can do a couple of these. These are the key questions, but you've probably done them by now. Or maybe you'll get a couple of freebies here. So let's take D here. We have x squared minus 7x minus 18. Now, you remember that our goal here is to find two numbers that multiply to give us 18, negative 18, and add together to give us minus 7. Okay, that's what you're looking for. Okay. So the way I do it is I just start writing factors of 18, and I don't worry about the signs. And I'll show you why. It's because once I get something that has a gap that's going to give me this number, now I'm interested in it. Now I'm going to spend my time looking at it. Because 2 times 9 is 18, and 9 minus 2 is 7. So the only thing we're missing here are the signs. Well, we can work this out. In order for that to be negative, the signs of these things have to be different. It means either 9 is positive and 2 is negative, or vice versa. So now we can turn our attention to the middle term, the negative 7, and say, all right, well, how do I get a negative 7 out of this? Well, the only real way to get a negative 7 is have minus 9 plus 2, correct? And it just so happens that negative 9 times positive 2 is negative 18. So now we can say with absolute confidence it's going to be x minus 9 x plus 2. And it doesn't matter what order the minus 9 and the plus 2. The signs are important, but it could be x minus 9, x plus 2, or x plus 2, x minus 9. It doesn't matter. Basically, this is the same as, 2 times 5 is exactly the same as 5 times 2. It doesn't matter. Okay. So that's how you do your factoring, and you probably want to get some practice doing that. Factoring. Okay, let's try another one here. I try the we always do the x's, but let's try one here like this e. This is kind of interesting. It's r squared plus 10r plus 9. It doesn't matter whether it's x or r, but k, doesn't matter what it is. So now this one's kind of cool, because whenever I see a 1 unit difference between them, that tells me something. It means it's going to be a very short factoring, because 1 and 9 is one way to make 9, but it's the only way to get a difference of 1, right? Any other way, 3 times 3, not going to work. So we know it's going to be 1 and 9. So how are we going to... So those are our factors, and now we just have to work out the signs. Well, if they're both positive, that actually works. They're both positive, right? So plus 1 plus 9 is going to be 10. So now I can write r plus 1 and then r plus 9. Right? Straightforward, just like that. Okay. So that's what you're looking for, and the more of these that you do, right, you'll see it. You'll be able to see things like that, where there's only a gap of 1, the factors are going to be 1 and this number right here. All right, I think we probably covered that. If you want to see a few more of those, this is your review, so you can send me a message on Facebook or email me or call me, and I'll be happy to put on a few more of those examples. Okay, sometimes you just want to see a few more. Okay, so now now that we've learned to factor, and this is a very important skill, we're going to use our ability to factor to find the roots of the quadratic equation. The roots are the places where it crosses the x-axis. Okay, and we do that in order to usually that's a point of interest for us. Usually, not always, but usually it is. So there's different ways we talk about it. We're solving a quadratic relation. It's called finding the zeros or the roots. And you know why? Why are there two ways to say it? I don't know. Um, really, there's a lot of things like that in math where there's a couple of different ways to do it. But you know what? If you think about browsing on the internet, right? How many different browsers do you have? You got Internet Explorer, right? You have Firefox, you have Chrome now, right? Apple has Safari, right? So you have all these different ways. So why do we need so many different ways? A lot of different ambitious people set out to solve the same problem. I think that's what we have here with finding roots or finding zeros. There's a lot of people were working on these problems, and we ended up with different terminology that means the same thing. So the way we find the zeros is we're gonna factor it. We put it in the standard equation in factored form, okay? And then we're gonna set each factor to 0 and then solve for the variable, right? And then that gives us the two values of the variable that make the equation equal to 0. In other words, where the 2 points, usually 2 points, not always, where it crosses the x-axis. Okay. Now, of course, having told you about all of that, then the first example, no, the second example I show you is a bit of a non-standard one like that. But it works out to be the same thing. Basically, we still need to factor it because what we need, we can't have any squares in the expression in order to factor. The other thing that is important is when we're factoring, at least the method that I've shown you up here, in this, we can't have a coefficient of the variable. We can't have a number there in front of the squared. To use this method that I showed you where you're going to find the sum and the product. Okay, it's if you have one there, you have to divide it out. And you know what I'm going to do is I'll show you next time a few examples of that, because that's a little tricky bit of business that they have where, oops, yeah, you have to factor out any leading number in front of the x squared first. All right, so we'll pick this up on Tuesday, okay, not Monday. Monday's a holiday, so we'll see you back here Tuesday.